Hello students, today we are going to start a new chapter, gravitation. This is for class 9, and before going to start this chapter, let me tell you about some situations that occur not only in our day-to-day life but also in the entire universe. As we all know that all the planets go around the sun, the moon goes around the earth, and the earth revolves around the sun. Apart from this, when we throw any objects vertically upward, then after reaching a certain height, it falls back to the ground. In all these situations, there must be some force which is responsible for that, and this is gravitational force. In this chapter, we shall study about the gravitational force, universal law of gravitation, the weight of an object vary from place to place, mass, weight, and many things. So let's start the chapter. Gravitation होता क्या है? So this is the force acts between two masses of an object. ये वो फोर्स होता है जो किसी भी दो ऑब्जेक्ट के बीच के मास पे लगने वाला फोर्स है. Every object in the universe attract every other object with a force which is called gravitational force. Clear? Universal law of gravitation. सर आइजैक न्यूटन ने एक यूनिवर्सल लॉ ऑफ ग्रेविटेशन दिया और इस लॉ के अकॉर्डिंगली उन्होंने बताया कि एवरी ऑब्जेक्ट इन द यूनिवर्स अट्रैक्ट एवरी अदर ऑब्जेक्ट विद ए फोर्स which is directly proportional to the masses of the objects, directly proportional to the product of the masses of an object, and it is inversely proportional to the square of the distance between them. So let me write down every object attracts every other object with a force which is directly proportional to the product of the masses of an object, and it is inversely proportional to the square of the distance between them. Distance between them. Clear? According to universal law of gravitation, every object attracts every other object with a force which is directly proportional to the product of the masses of an object, and it is inversely proportional to the square of the distance between them. Suppose two objects are here. Its mass is small capital M, its mass is M. The distance between the center of the two objects is this is the difference between the center of the two objects. Its mass is capital M, its mass is small m. This is A, this is B. Clear? And the force acting between the two objects is F. So, according to the universal law of gravitation, F is proportional to m into m. F is proportional to m into m, it means if the mass increases, then the force also increases. And if the mass is less, then the force is also less. More mass, more force. If the mass of an object is more, then the force applied by an object will be also more. And if the mass is less mass, then less force is applied. Clear? And if it is inversely proportional to the square of the distance between them, it means if distance is less, more force is more, and if the distance is more, then the less force. So here we can write F proportional to mm by r square, that is F equal to G m into m by r square, where G is gravitational constant. G is gravitational constant. So this is the formula of gravitational force. And if we have to find out the SI unit of gravitational constant, SI unit of gravitational constant, F equal to G mm by r square. Here we can write F r square equal to G mm g mm equal to fr square. So g equal to fr square by m into m. So g equal to SI unit of force is Newton, radius is the r is the distance, so unit will be m square, kg and kg. So SI unit is Newton meter square per kg square. If its value is 6.673 into 10 to the power minus 11 Newton meter square per kg square. Clear? Now, what is the importance of the universal law of gravitation? We have studied about the universal law of gravitation, and now we are going to study about the importance of universal law of gravitation. So as we all know that many phenomena were explained successfully by the help of universal law of gravitation, which are unconnected earlier. So importance of universal law of gravitation. Several phenomena which are unconnected were explained successfully with the help of universal law of gravitation. Like the force that binds us to the earth. Clear? Second is the motion of the moon around the earth. Then it also explained about the motion of the planets around the sun and tides due to the sun and the moon. So these are the phenomena which are explained by the help of universal law of gravitation. First one is the force that binds us to the earth. Second is the motion of the moon around the earth. Then the motion of the planets around the sun. And then the tides which are due to the sun and the moon. Clear? Now we will study about free fall. What is free fall? Falling of an object from a height under the influence of gravitational force of the earth is called free falling object. Free falling object. What is free fall? So when we drop any object from a certain height, it falls under the influence of gravitational force of the earth, and then the such type of object is said to be in the free fall. You know, when the object falls downward, then the velocity of the object changes continuously, and we all know that when there is a change in velocity, it means acceleration is involved. Suppose this is object, this is the ground. When the object falls on this ground from this height, in this case the velocity is at this position, velocity will be 1 meter. Another position, then the velocity will be different, like 2 meter. And at another position, then the value of the velocity also increases. That means when object is falls, acceleration is involved. Acceleration is involved due to the change in velocity of an object. And this is due to the gravitational force of the earth. So the acceleration is called acceleration due to gravity. See, जब भी कोई ऑब्जेक्ट नीचे गिरता है तो ऑब्जेक्ट का वेलोसिटी चेंज होता है. ऑब्जेक्ट के गिरने में अर्थ हमेशा इस पर ग्रेविटेशनल फोर्स लगाएगा, और चूंकि ग्रेविटेशनल फोर्स इस पर लग रहा है तो एक्सेलरेशन इज इन्वॉल्व, एंड दिस एक्सेलरेशन इज ड्यू टू ग्रेविटेशनल फोर्स ऑफ द अर्थ. So this acceleration is said to be acceleration due to gravity, or we can also say gravitational acceleration. Acceleration due to gravity. कैसे इसको डिफाइन करेंगे? तो as acceleration is involved in free fall and the acceleration is due to the gravitational force of the earth, so it is called acceleration due to gravity or gravitational acceleration. Clear? It is denoted by small g. इसे बड़ा रेस्पेक्ट से इसका नाम दिया जाता है g. And its SI unit is the same as the acceleration, so its SI unit is also meter per second square. The value for G is does not depend on the mass of an object or small object. स्मॉल जी का वैल्यू किसी भी ऑब्जेक्ट के मास पर डिपेंड नहीं करता है. ऑब्जेक्ट बड़ा हो या छोटा हो, दैट डजंट मैटर. नाउ वी विल फाइंड आउट द वैल्यू ऑफ जी, हाउ इट विल बी कैलकुलेटेड. From the second law of motion, Newton's second law. Newton's second law of motion, force is the product of mass and acceleration. Let the mass of a stone is m and its acceleration is g. Let M is the mass of free falling object, and as we know that acceleration is involved in free fall, it is denoted by small g. According to Newton's second law of motion. According to Newton's second law of motion, what we studied? So we have studied in the Newton's second law of motion is force is the product of mass and acceleration. Force equal to mass into acceleration. That is F equal to m into g, where g is the acceleration due to gravity, and according to Newton's universal law of gravitation, F equal to g m by r square. This is equation first, this is equation second. See, m is the mass of free falling object, and as we know that acceleration is involved during the free fall, and this acceleration is only due to the gravitational force of the earth. So this acceleration is said to be gravitational acceleration, or we can also say acceleration is due to gravity. Clear? And we have studied in the Newton's second law of motion, force equal to product of mass and acceleration. Here F equal to m into g, where g will be the acceleration due to gravity. And according to Newton's universal law of gravitation, what we have studied, F equal to g mm by r square. Now we equate this equation. By equating equation 1 and equation 2, mg equal to g mm by r square. Mm cancel, so g equal to g m by r square. If we put the value of g equal to 6.673 into 10 to the power minus 11 Newton meter square per kg square. M, which is the mass of earth, equal to 6.4 into 6 into 10 to the power 24 kg, and r, which is the radius of earth, and this is 6.4 into 10 to the power 6 meter. So G equal to 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 by 6.4 into 10 to the power 6 square. After calculation, we will find G equal to 9.8. Unit will be the same as the acceleration. So this is the formula of acceleration and this is the value of gravitational acceleration. Clear? Now we see mass and weight of an object. What is mass? Mass is the quantity of an object that contained in it. We can also say mass is the measurement of an inertia. In the previous chapter we have studied about the inertia. What is inertia? Inertia is the property of any object that opposes the change of state or motion. That means if the object is in the position of rest, then the object wants to be in the position of rest, and if it is in the motion, it wants to be in the motion only due to the inertia. Mass is a constant quantity. Mass it does not change from place to place. It has only magnitude, so it is a scalar quantity. Its SI unit is kg. Clear? Now we come to weight. So as we know that the earth attracts every other object. That means an object is attracted by the earth with a force which is also called the weight. It is the force that acts on an object vertically downward. Vertically downward. As we know that F equal to m into A, m into A will be G, and if this is weight, so W equal to m into Z. SI unit of weight is the same as the force, so its SI unit is Newton. Weight is the measurement of gravity. It varies from place to place. It is a vector quantity. Weight is the force of an object that acts vertically downward. And this is due to the gravity, so we can also say weight is the measurement of gravity. And as we know that force is weight, so its SI unit is Newton. It is a vector quantity because it is a force and it has both magnitude and direction. So this is a vector quantity. Clear? Now we have a question. Weight of an object on the moon is 1/6 of the weight of an object on the earth. That is, weight of an object on the moon equal to 1/6 into weight of the object on the earth. We have to prove that. Now we see weight of an object on the surface of the moon is 1/6 of the weight of an object on the surface of the earth. Now we have to prove it. What we will do? So let m is the mass of an object. Clear? Now the weight of an object on the moon will be Wm. The weight of an object on the earth will be Wa. According to universal law of gravitation, We equal to G me into m by Re whole square. G will be the gravitational constant, me is the mass of the earth, and m will be the mass of an object, and Re is the radius of the earth. Then Wm equal to G mm into m by Rm square. Now W by Wm, that is G me into m by Re whole square into Rm will be here by G mm into m. G cancel, mass will be cancel. Now We by Wm equal to me by mm into Rm by Re whole square. Now by substituting the value of mass of the earth, mass of the moon, radius of the earth. So as we know that mass of the earth will be 5.98 into 10 to the power 24 kg. Mass of the moon will be 7.36 into 10 to the power 22 kg. Radius of the earth will be 6.4 into 10 to the power 6 meter, and radius of the moon will be 1.74 into 10 to the power 6 meter. Now see, Wm by We equal to Me, 5.98 into 10 to the power 24, 7.36 into 10 to the power 22, 1.74 into 10 to the power 6 by 1, 6.4 into 10 to the power 6. Cancel. After calculation, we will find 0.165, which is equivalent to 1 by 6. That is Wm by We. Wm equal to 1 by 6 into We. And this way we can say that the weight of an object on the surface of the moon is 1 by 6 of the weight of an object on the earth. Clear? So now we will solve some numerical problem on the basis of this formula. Thank you.